we're back to talk about the division algorithm. Hopefully you read the slides and looked at the examples and the definition, or what we mean by the division algorithm, but I just wanted to chat about that with you here. So given a and b in the integers, b greater than 0, there exists a q and an r such that a is equal to b times q plus r. And these q and r are unique. There's only one pair, q and r, that's going to do the job. And one of the things that makes that unique is that we are going to say that 0, or r, always has to be between 0 and b. Okay? And this is also going to make things a little bit different when we calculate if we have a negative involved. So first we'll start with an example. If I say a is 37 and b is 5, and I'm looking for q and r, then to find those, I can basically do elementary school long division, right? So if I go back in time and say, all right, I'm looking for q and r in this problem, all I'm doing is basic long division. So 5 doesn't go into 3, but it goes into 37 7 times. We go ahead, 7 times 5 is 35, 5 does not go in 2, so we would say that 37 divided by 5 is 7, remainder 2. So we could rewrite a, 37, as 7 times 5 plus 2. Okay. So our q here is the 7, and our r is 2. And it fits this definition here, right? Like I said, these are unique because of this condition up here. Now, just to switch things up here just a little bit, what would happen if I wrote negative 37 instead of positive 37? And if I tried to do that same thing up here, you probably never did long division with negative numbers. Okay, so maybe I go back and I sort of look back at a calculator. Maybe I try that. Maybe that'll tell me the answer. And if I do negative 37 divided by 5, I get negative 7.4. Okay, so maybe you stop and you try to think about that, and you go, okay, so negative 37 is going to be negative 7 times 5. But to make this actually be true, we'd have to subtract 2, right? Because this is negative 35. So to make this equal, I'd have to have a negative 2 here. But that's not what the division algorithm says. The division algorithm says I always have this positive remainder here. So this isn't quite right here. So what you have to do, if you're going to use a calculator to do this, is whatever answer you get here, you always have to take the floor of this function. So you always round down to find your q. So if we take the floor of this function, rounding down from negative 7.4, we get negative 8. So then, going back here, if I do negative 8 times 5, I get negative 40. So to get to negative 37, I would have to add a 3. Okay? So if we did this, our q would be negative 8, and our r would be 3. So remember, we always want to add something to get up to our number. You can kind of think of it in terms of a number line. You're always wanting to add something, so you're always wanting to go to the right. So think of it, you're trying to do 37, and you're counting by 5s. So 5, 10, 15, 20, 25, 30, 35. And you go everything you can up until that, and then so you would add that last 2. And if you were doing it in the negative direction, the idea being you count by 5s, -10, -15, -20, -25, -30, -35, and then you overshoot the thing so that you actually have to add back to it. So you always want to have to move, if you're thinking about a number line, you're always wanting to have your remainder add something to it. So you're sort of, here you go everything before 37, here you have to go a little past -37.